minutes to talk about our tool. So, since it's a very short time, I want to show you any snapshots or anything, but just the concepts we're trying to implement. And that will probably show where also we are aiming at. So, first, we come from the modeling side. We don't come from the testing side. Testing was introduced later on. So when we talk about models, we really talk about models you can implement. It's not only models to generate tests, but it's really models you can implement. We have integrations with real-time operating systems, for example. We have integration with debuggers and things like that. So, and most of our customers use models to generate code and do, let's say, concrete products. So the company is really focusing on the tool for modeling and now also on the testing. And the technologies we use work for communicating system or event-driven systems. So you know the problem about software complexity. I think people have been repeating that all the time. From our point of view, the key issue here is about understanding what you're supposed to do. You know, what's the objective of your development. And one of the interesting figures here is that most of the defects come from the wrong understanding of the requirements. So the early we can verify things, the better it is. And we all agree on that. Okay? So that illustrates that, like a problem you can have, like something has been developed and it's not what you were expecting. So to solve that issue, we will work on models, and the model is a way to describe what you want to do, and try to get away from the how you want to do it and really focus on the what. And when you think of building a house, okay, you wouldn't think of building a house without having plans, because plans are here to communicate and determine what you're trying to do. And then in the end, when you get your final product, you want to check that it matches your initial requirements. Okay, so the more precise the plan is, okay, the more likely you will get what you expect. And that's where our first thought in the beginning it was to say, when you talk about software, if you want to build a model of your software, the more precise it is, the more likely the software you develop will be what you expected. So the modeling language you use to describe the model is very important. And the modeling technologies we have chosen in our tool are executable technologies, because a model of a software which is just static is basically useless. All systems now are communicating, and the dynamic aspect must be verified very early. So we have, let's say on the left side of the P cycle, used a technology that can be executed, which is called SDL, you probably have heard of. And on the right side, we have used TTCN3 because it's also executable. Now in the tool, because we are pragmatic, as you understood by the name of the company, pragmatic people, some users want very precise models, and some others are less precise. They don't need a very precise model. So you can have different levels of let's say, precision in your model. So we actually support formal models. So there's no code element, it's just a model, very abstract. Or semi-formal model, and that basically means that you can insert code within your model, because your model is just an abstraction of the code. So if you're aiming at implementing a product very quickly without spending too much time verifying the model, it's interesting to have code within the model. So if you look at the P cycle, which is not there yet, at the top level, when it comes to requirement, we use basically two technologies to express requirements. The first one is the MSC, the message sequence chart. So it's like the diagrams you saw at the presentation before, the exchange of messages, and then you can express basic scenarios. And then we are now working with the property sequence chart, because it's not only a matter of standard scenarios, it's also a matter of defining properties on the system and verifying the properties on the system. And that's a good way to express a requirement. If that happens, the system should do this. That's a property of the system. Then out of these message sequence chart or property sequence chart, we can generate test cases very early in the development process. So from MSC to TTCN, for example, or we can verify the properties on a system simulation, for example. On the left side, we can further describe the system model and then verify with simulation techniques that the properties and the requirements are also fulfilled by the system. And then we worked on how to move from one side to the other. So for example, if you have a model and you use your model as a reference, how can we generate test cases out of it? And then we have different techniques to do that. A very basic one is to simulate the model and then to generate the test cases so that you can replay the scenarios you have just manually simulated. Or you can automate things. For example, you can define a test objective and use a tool that will search for all the paths to get to the test objective. And for that, we use third-party technologies because it's very, very complex. And the latest technology we're implementing is one coming from the CEA, which is the Nuclear Research Center in France. And that technology will allow to generate a minimum number of test cases that will cover all transitions in the model. Now, also the basic things about a model that is executable and a test that is executable is that you can run the test against the model very early in the development process, whether you have been generating the test cases or not. Once the model is valid, once the test cases are being written, we can, in the tool, generate the code, go down to target from the model, or generate the code out of the test cases and run the test cases on the tester. So that's a few of the technologies we use. I've talked about MSC, STL, PSC, and so on, and that's what we get out of these technologies. Formal modeling, model-based testing, model checking, property verification, validation, and coverage of the test cases. So as a conclusion, the tools we have are set different levels of modeling, and actually the more formal we are, the more things we can do. We can verify the model, we can generate test cases, and so on. And all this is based on standard technologies. I'm done. If you have any questions, or if you want to see the tool, because I didn't show the tool, we are behind that wall. No questions?
I have a question. What is the place of TTCN3, your suit or your approach? I saw TTCN3, you generate TTCN3 mode.
Yeah, on the right branch of the B side, we use TTCN3 all along. So it's mainly for testing.
Okay, but do you have an engine, TTCN3 engine, or you compile only generate TTCN3 code? You run TTCN3?
So we have a TTCN3 editor, which is just text editor, so that's quite basic. Then you can generate TTCN3 out of a model. You can simulate TTCN3. We have a TTCN3 simulator, and we can generate code out of TTCN3.